you might have heard earlier, my name's Nate Newton. I'm with IBM Cloud, here with Cisco today to kind of talk about the work that I've been doing and that they've been doing with SaltStack and Proxy minions. So if you don't know, I mean, probably all of y'all are familiar with, you use SaltStack, you put the minion on the box, it does the things, life is good. Well, when you have a bunch of network devices, you can't really do that. But SaltStack has us covered, has the ability to control devices that you can't install minions on through the use of Salt Proxy minions. Now, the team I'm part of at IBM Cloud, the network and engineering team, we manage the physical network, and we selected Salt Proxy minions and NAPALM kind of try to amplify our ability to control and manage the devices that we have. Now, Cisco is one of our primary vendors. We have a lot of their gear out there, and so they kind of recognize the value of using Salt to manage network devices so we could have a streamlined, consistent process across all our data centers. And so they're here to talk about what they've been working on with their native support for SaltStack. So, kind of what we're going to cover, or at least I will, just exploring our use case to it, how you can use Salt to do software-defined network on a physical infrastructure. We did to audit our infrastructure, confirm the supportability of our devices, and move into streamlining our deployment of Salt. We'll talk about what we did there with having to do a bunch of upgrades and then focus on a data-driven deployment of Salt. Because, you gotta write a config for each proxy minion. There's a bunch of them. I'm a pretty terrible typist. Can you not hear me? Do I need to speak up? Oh, yeah, sure. Sorry. Can everybody hear me now? Good? Much better. All right, sorry about that. To that, kind of go into what we learned from going through this process, and then looking to the future, things we want to change, and things that we can do better. So just kind of exploring these cases. As you probably mentioned or heard earlier, we have a fairly large network. The 80 plus data centers, POPs around the world. Really, yeah, I mean, it's closer to 70,000 devices at this point. I probably should have updated that. But we're running a big infrastructure, and we don't have that many people to run it. So we started looking for ways to automate. And so Salt Proxy minions came to mind. They can connect to a wide range of networking devices because, we've got Cisco, but we've got a few other people out there. Proxy minions configured using all the familiar capabilities provided by Salt. So you can use those and you get advantage to, take advantage of everything that Salt provides. Sorry. All right. So, yeah. So we can do change management. Sorry, my head around this. All right, change management can be controlled using, execution modules and reactors, and you're familiar, probably if you've been to a bunch of the talks already, the beacons, reactors, so we can use that to do dynamic management of the network. Leveraging those capabilities, we can centrally manage, programmatically manage, and easily update and quickly audit our network. Now, we had this slide already. We've got tens of thousands of Cisco's, a lot of Arista, quite a bit of Juniper, and then a smattering of other smaller vendors for firewalls and load balancers and whatnot. Now, having this range of devices, we were interested in NAPALM because you may or may not know, it kind of works as an abstraction layer. It allows you to use Salt Proxy minions to access a variety of devices using one kind of proxy, which sounds really good, and it works on a lot of devices, but we found that, there were a lot of devices that it couldn't work with because they didn't meet the requirements. The firmware version was old, real old, and so that was kind of our first challenge in trying to do this. So streamlining our deployment. We have, God, I hate to say this, thousands of devices that are running firmware so old you can't get it from Cisco anymore. So we needed to take care of that before we could actually even start using Salt. That's really most of what I'm going to talk about. So, in partnership with SaltStack's professional services team, Gary Richmond and Adrienne Malaguti came on site to help me start building a state and a process to go out and find all these NXOS devices. It's mostly 3Ks and 5Ks out there running version 4, version 5.02 on our network that needed to be upgraded to be able to leverage the work they've been doing and leverage the NX API, as well as kill a bunch of security vulnerabilities that are out there in those firmwares. But you can't just do that. You can't take a switch that's on 5 and jump it straight to 7 or 9. You have to do step upgrades. Has to be a sequence and coordinated, especially since most of these switches are deployed in a VPC pair, so we've got a primary, secondary. We can't blast the primary up from 5 to 7 and leave the secondary hanging in the wind. We'll just, you'll kill it. So we had to carefully construct tests in a lab that didn't have customers on it to make sure this would work. So going through the state, actually, I'm going to talk about that. So we built a state that would upgrade, like a Nexus 3K from 5 to 7 that's in a pair. So it kind of goes through and does all the checks that you would do if you were doing it manually. So we log into the device, confirm the firmware version it's running, look at its neighbor, see what firmware version it's running, validate that it's a good VPC pair. You check the state that the one you're on, check the state of the neighbor, and then compare that. So we built a map of firmware versions, compare the version you have against the map, and then look to see if you're on the secondary device. Then if you are, you can go ahead. So that you know the rest of the process of copying the new firmware out, checking the MD5 checksum, make sure it got there okay, and then doing the install show all and have the switch run its own checks on the firmware you loaded before you hit the button and upgrade it. And so what this state allowed us to do was just point Salt at a pair of devices, rather a bunch of pairs of devices, and run the state, and it'll figure out who's primary, who's secondary, upgrade it, run it again, upgrade the other one, and just kind of go back and forth until they reach the version of firmware that we want them at. Now, I mentioned probably too many times, we've got a bunch of devices. So that means a bunch of Salt proxy minions. Now, each Salt proxy minion has to have its own config. Now, originally, just for testing, we were writing out the config files, but that doesn't scale when you have to do it on 80 different servers around the world. So what we did was we used NetBox as kind of an inventory to keep track of our networking. If you're not familiar with it, it's a great tool. It's from the guys at DigitalOcean. It's open source. But that lets us store an inventory of our devices in there. And so what we did was make an external pillar that can talk to NetBox through its API. And then that lets us allow Salt to figure out what devices it should be managing. So we turn up, one of our Salt containers. It goes out, hits NetBox, says, okay, I'm in Dallas. I need to grab all of these Dallas Nexus switches. And then it starts up the proxies for each of them, and it's ready to go. So that kind of allows us just to, I guess I should step back and say that we're running Salt in a Docker container. That's for a couple reasons, but so we can just deploy this container, and then it comes online and figures out who it needs to be managing. We got here, for those of you who aren't familiar with what configuration for a proxy looks like. This is for the NXOS proxy for Cisco devices. It's the one we had to use. It allows you to access the device through SSH. So since these are on old firmware, we don't have the API. So this is actually what we would generate with the external pillar data. When it says start a proxy minion, it goes out to Netbox, pulls out this information, puts it in a Python dictionary, and it ends up in the main pillar data of the Saltmaster. And this is kind of reiterating, we would like to use the API. We're kind of stuck using things over SSH and screen scraping and using text FSM to filter the results that come back from the switch. But once the firmware is upgraded, we can use NAPALM, or we can use what they've been working on, which is what I'm more excited about. All right. So lessons learned. Have to. I'm not going to skip that. Y'all can read it. All right. So lessons learned. First one is inventory control. We really had to have a good handle on what's out there, what firmware it's running, and for us in a central location that we could have all of these Saltmasters running. I guess I probably skipped over that. So for each 500 devices, we're running one Saltmaster. So if we've got, 5,000 Nexus switches, we're running 10 Saltmasters. So having it in a central location they can call back to was important. To support, data-driven and not having to write it. Yeah?
Are you running the proxies on the same machine as the master itself?
Yes, I should have mentioned that. So in one container, there's a Salt master, a local minion, and in our case, 500 proxies running. And the local minion, it's there just to manage the proxies. I'll get to why that's the case in a minute. Sorry. Now moving forward, we kind of would like to use NAPALM to an extent because it gives us one type of proxy to look at, not have to worry about using multiple ones. I mean, obviously there's going to be cases where NAPALM doesn't fit the bill and we'll have to fall back to using another one. And also because it affords us the ability to work with other than Cisco devices through contributions of community members to the project. Managing Salt proxy processes. Like I said, the external pillar data is from Netbox. That where we get the configuration for the proxies. And that's all based on the geography. So when the Salt master comes up, it knows what data center it's in and where it's at, and so it can filter the devices. Now, I'm saying we're running them in containers because in testing this out, I initially just flat installed it on a pretty beefy server and found that when you start bringing up 2,500, 3,000 proxy minions on one box, well, for one, it uses a lot of memory. I mean, I think we were pushing like 400 gigs of RAM. Mostly on the authentication, we were pegging the CPU at a box with two 18-core Xeons in it. But what we found is the event bus has a problem. When you start throwing that many queue requests at it, it chugs and slows way down. So doing something like that, while it'll eventually run, takes about half an hour before it turns up completely, and you can start even running test ping against it. So to kind of get around that, that's why we started putting Salt in a container, because even though I'm running the same number of proxy minions on the same device, having it split up into multiple masters with only 500 proxies querying each master, it kind of resolved that. It all comes up within a minute, and you can immediately start using it. Now, we picked 500 to give us a little buffer. You can actually run that up to about 750 or 1,000 and still have it go, but yeah. 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 Yeah, it was really only, I mean, you see a slowdown if you run, obviously if you go 3,000 devices and say, hey, go do show run on all these devices, it's not super fast. I mean, you still have to wait for everything to, process and come back. Now you're, remember right, order of 5-7 minutes, which is, I guess not terrible. But yeah, I'm initially just talking about when the proxies all come online and try to do the key exchange with the master, that really mungs things up. Oh, so yeah, that's a good question. So right now each proxy is just talking to one dedicated master. Kind of the way we setting this up in containers, if one master has a huge problem, we'll just turn it off and start a new one, and it'll pull down the same devices and pick up right, where it left off. So I guess kind of going into the next step, so what do you do when you've got a whole bunch of masters? Well, we picked to go with SaltStack Enterprise. Probably not available to everybody because you have to pay for it, and it wasn't completely cheap. But that gives us the ability for all of those masters to call back to SaltStack Enterprise, because, as Christian mentioned, I'm running, well, if you're not familiar with SaltStack Enterprise, there's really 3 parts to it. There's the plugin that goes on the master, there's the ROS service that runs, and then there's the Postgres database. Now, so what we're doing is running one master in each data center and by our enterprise. So every master's got the plugin, we're running one service in a data center, and all those masters talk back to that enterprise server. And then all of the enterprise servers talk back to one Postgres database. And so what that affords us is it doesn't matter which enterprise web page you log into, you'll see all of the same proxies on it. Now you could do that individually, but I mean, that was kind of a complaint from the engineers. I don't want to have 10 different things to log into to manage devices across the world, because I got to do changes in Tokyo and then Dallas. Just give me one thing to look at. That's a pretty good size because we'd already, that's not something I manage. It's actually provided by another group and they use it for a bunch of stuff. So really all I had to do was give them the schema and have them load it up. So. Yeah. I would love to answer that question, but that's just kind of outside of what I dealt with. I'm sorry. All right, so I kind of mentioned the resources usage, which led us to looking at if there was a better way to do it. So don't really want to keep deploying really expensive servers across the world to manage this. And so we'd found in the community a group of people who had actually gotten the minion installed on a switch and running and able to send commands to it and manage it. I'm like, well, that's pretty cool. So that's when we went to Cisco and said, hey, we've got a bunch of your switches. Can y'all do this? And they were like, yeah, get newer firmware. Or if it was really old, hey, how would you like to buy a new 9K? But so I guess I just kind of hand it over to them and let them talk about work they do. Yeah, sorry.
Hi, so my name is Gerard Sheehan. I'm a product manager at Cisco. And before I go any further, I just want to get a level set of the room. How many of you have Nexus platforms and Nexus 7Ks, Nexus 9Ks, a hybrid, 7Ks, 3Ks, 5Ks? Most customers have a mix of both. Okay. Just want to get a level set. Thank you. So some of you may be familiar with what we call the GuestShell. So the GuestShell works on Nexus 3000s and Nexus 9000s. It's a CentOS VM. So this is on 7x and beyond code, and I will go into the specific releases shortly. But it's an isolated LXC container that runs on box. So you can yum install whatever packages or whatever applications you want and run natively on the box. And when IBM came to us, we said this is an ideal way to run that proxy on box so that it can be managed and, as Nate said, to take the load off those servers. So GuestShell is supported on Nexus 3000s and Nexus 9000s. It has access to native, to the boot flash, it has access to the CLI, and it has the same, you can enforce the same RBAC as you would through NXOS, through the terminal itself. So one of the things, the initial complaints we got from customers was around how you can, because each individual GuestShell had to be managed on the box. So you needed to log into the device, enter the GuestShell, and then configure it. And this just wasn't applicable at the scale that customers are looking to leverage. So for that, what we have is called GuestShell import export. So it means that on a development machine, you can customize it. You can install whatever applications you want, configure whatever RBAC you need, install whatever yum repos you want, and in this situation, you can install that Salt minion on box, and it can then be deployed from that initial development machine. So we also have, for those not familiar with it, we have, this can be deployed via POPE. Sometimes it's called ZTP, it's day zero provisioning, but it's also a way of upgrading and managing devices. So it's POPE being power on auto provisioning, or ZTP, zero touch provisioning. So this GuestShell can then be exported to an OVA and deployed via POPE. So these are the platforms and the releases under which it can be supported. So like I said, it's supported on Nexus 3000s and Nexus 9000s. Support was recently added for the Nexus 3500. But so that proxy can then be installed on these platforms. Now, the GuestShell will not be supported on the older platforms, the 7000s, 5000s, etc. But Mike will go into details around a common implementation and a common interface across all of these platforms, regardless of if it's an on-box minion or if it's a proxy minion. No, no. So the Nexus 5000s, the resources aren't available on that platform to run the GuestShell on box. Now, Mike will go into the details of it, but there is a way to have a common interface for a proxy minion as well as an on-box minion that can address those 5Ks and 7Ks. So in our most recent release in July, we added the ability to run Docker containers on box. So we are also in a Q1 timeframe of next calendar year. We will looking to validate running this within a Docker container on top of NXOS. The initial implementation will be in the GuestShell, as I mentioned previously, but this is to run Docker containers on the box. So there is the ability to get, we have an SDK, it's called NX SDK, so it allows you to get API callbacks natively from NXOS. These are the same APIs that NXOS uses itself, and these are available to containers to run on box to get that. So it allows for a tighter integration between that minion on box with the underlying infrastructure to get the data to build those salt states, etc., that would be required on box. Again, it has access to NX API and our DME, which is our data management engine, and it has the same shared access to boot flash, CLI, and volatile storage. And that is the end of the marketing pitch. Mike is here to talk engineering.
All right, good morning. So I want to talk a little bit more about what we actually did. So as I'd mentioned in the keynote, my team, I've got a small engineering team. We're responsible for integration of open source technology like SaltStack on our NXOS data center switches. And when we started this journey, I think it was just about 3 months ago. We hadn't actually been working with the technology that long. So I'm learning a lot from you all and from the different breakout sessions. But we started this journey with 4 goals. We wanted to combine the existing NXOS capabilities that are already part of Salt Open. We wanted to combine that into a single namespace. I'll talk more about what that means in just a moment. But we really wanted to have, the second thing is we wanted to have the same look and feel, regardless of whether you're going over a proxy minion or an on-box minion. So the same API, same functionality available to you. So the third thing is we wanted to make it easier in the future. So when Nate wants to add new functionality, there's one place where he can now add future execution modules, salt states, custom grains, beacons. So there's just a common integration point there. And then finally, ultimately, I know that NAPALM is really attractive because of the fact that it can run across a heterogeneous network. And so being able to provide an integration point, so we're going to start looking at what it would take to actually run NAPALM on box as well, not just over a proxy minion. And so that's kind of, it set the stage for that integration. So here's some of the details of what we did. So when I started looking at Salt Open, I looked and I noticed there was actually 2 completely different namespaces for managing NXOS. One was for the NX API, which is it's the on-box API that exposes CLI over HTTP or HTTPS. And then there was a separate namespace that had existed for some time for managing these boxes over SSH. So I looked at it and I said, you know what, this would be a great opportunity to basically do several things. Combine these into one single namespace. And that way, we have one place where we add these future execution modules and salt states and whatnot. But also, the other thing is that it actually gave us a library, exposes a library that we can then integrate with NAPALM. And so when we're running over a proxy minion, functions just like it normally does today for NAPALM, but then if we're running on box, we can just access this local connection to NX API and extend those capabilities to wherever GuestShell is supported. And so that's really why we embarked on this journey. So what does this converged picture look like? Well, you look here, you can see that now everything, this is actually just committed like 3 days ago. This is available in the develop branch. You can see here that we now can manage at the top. We've got, the top block is for proxy minion configuration. The bottom block is for on-box native minions. But if you look at that top box, there's a couple things I want to point out. So everything is in that common namespace. So the proxy type is NXOS. There's an NXOS _ API that was also used for NX API support. But all the functionality from that, all the functionality from the SSH namespace has all been combined into one. So all the grains, all the execution modules, those are all available now over both proxy minion types. So if you see there in black, the black parameters, and I've got the label there too as well, common params, you've got the typical things of my host name, my username and password, and there's one additional parameter that we've added called no-save-config. I'll talk about that in a minute, why. But then you see there in the maroon or purple or brown, whatever color you see, I'm not sure, it's the SSH parameters, and then of course at the bottom in green are the NX API parameters. Now, the no-save config option is something that I added because part of the legacy behavior that I noticed is that whenever you send a configuration command to the device, there was about a 6 to 7 second tax on every single configuration command. And the reason why, I looked at why are we taxing it that way, it's because it was actually copying the running config to the startup config, and that takes a little while on Nexus devices. And so I thought, well, I'll preserve the backward compatibility, but I'll give you an option to turn that off. And then add another execution module function, save running config, NXOS.save running config to basically save all your configuration commands at the end. And so that cut, like out of salt states where there's 24 states, went from like 90-second execution time to 13 seconds. So it's pretty significant time savings there, just a simple thing that we changed and added there. So if you look at the bottom, the existing minion that was able to run on box with NX API, still connected over HTTP or HTTPS. Using the new namespace and the streamlined code, you no longer have to specify all the parameters at the top, host name, username, password, connection information, because we're using a local connection inside the guest shell with a native minion. So we just connect directly to NX API using that local connection. So the only thing you need, in fact, you don't even need these two parameters at the bottom. You can add those to your minion configuration file. We've already talked about no save config, what that means. But then there's also this parameter called cookie. What is cookie? Well, if you're using the minion on box and you're using an account that's a non-admin user account, you can specify a cookie to be whatever that user is. And so you can actually connect using that user instead. And so that's an additional capability that we've added initially. So we looked at this as a proof of concept. Let me just do a quick time check here. So we looked at this as an initial proof of concept where we took a minion that can run as a proxy minion or a native minion, streamlined the code, re-architected it a little bit, said this is a great proof of concept for now. How do we extend NAPALM capabilities to run on box? And so that's kind of one of the future next phases that we're looking into, so that Nate can have access to NAPALM capabilities across his Nexus devices and still be able to use it as a proxy minion as well. But it gives you some nice additional capabilities, and you have two different places, SaltStack Open or NAPALM, where you can make future contributions and take advantage of the community as well. And so we think there's areas like custom patching, upgrades. Those are probably places where we make more contributions to Salt Open directly, specifically around NXOS. But NAPALM is certainly attractive for more heterogeneous networks. Okay, so this just kind of gives you a quick snapshot of what we support and where. So N3K, we support all three types of minions. N9K, we support all three types of minions, assuming the firmware version is what Gerard showed us earlier. 5Ks, we support SSH proxy minion. And the N7K, we support NX API and SSH. But I want to hammer home again that all the functionality that's available for all these minions is now combined. That wasn't true until about 3 days ago. So, for what that's worth. Okay, there's nothing magical about this slide. This just says it's really easy to install the minion inside GuestShell. It's just a yum workflow. So just you add your CentOS 7 repository, yum install it, configure it, start the minion, accept the key, you're good to go. All right, so I want to do a quick little demo. So let me end the slideshow here. And I'm hoping to do a live demo. Everyone who's done a live demo knows that live demos don't often go well, but
It worked earlier.
yeah, it did work earlier. All right, so yeah, so I'm gonna. All right, I've got my little script here. I'm just gonna cut and paste these things. So you can see here, I'm running my SaltStack master right on my Mac here. I am going to go ahead and go over here. You can see at the top is my SaltStack master. In green, I've got 3 different kind of minions. This is my N9K running the onbox minion. This right here is my N3K running the onbox minion. And this over here is my N7K running the proxy minion. So first thing I'll do is I'm actually going to start up. I'll just show you. I've already pre-installed Salt. I'm going to go ahead and start up my minion right here. So it starts up. Oh, got to go ahead and select the keys. So let me go up here and see. Okay, so I can see that my 9K GuestShell minion wants to connect. So let me go ahead and accept that key. Excellent. Wait till it's ready to receive requests. Awesome. All right, so let me go ahead and display. We've got some NXOS grains. Excellent. So those are some custom grains that we can expand on later. Let me go ahead and start my 3K. should have made my script bigger. I can barely see this. All right, so that minion starts. I've already accepted the key for that, so it's ready to receive requests. I'll go ahead and look at my N3K grains. One thing I want to point out is this is actually a low footprint 3K, which is important. Got a lot less boot flash to worry about here, so it's about 600 megabytes you can play with. The minion does install on that low footprint with some room to spare, so it is supported for you if you have lower footprint 3048 version N3Ks will still work there. And then on my my 7K, let me go ahead and start the proxy minion there. And you can see here that it's going to connect over SSH. And if I just say, okay, you know what, just give me grains for all of them, just add that wildcard there, goes through, and you can see there I've got grains for all 3 of my devices. I'm going to stop the proxy menu really quick, and I'm just going to show you the content that I have in there. So we've got this new connection type. I actually think I failed to mention the connection type. So that's actually a new parameter that we've added. So you can control what transport you want to connect over. So right now you can see that I'm connecting over SSH. But if I want to connect over NX API, then I just specify the connection parameter NX API, and it'll connect over that. By default, if you omit this parameter completely, it just defaults to connect over SSH. So I am going to just go in here and edit this really quick because we saw it connect over SSH. Just want to make sure that I'm not lying to you, and that we can see it connecting over NX API. All right, so let's connect proxy. It's going to go, and you can see here I am actually connecting over HTTPS. All right. So I'm going to go ahead and wrap up the demo. I had a few more things to show, but just kind of configuration things and show things, and you guys can do that on your own. But I'm going to leave the last 5 minutes here for questions. So any questions? Yes. Yes, that's correct. Yep, you can use it for whatever you want. Yep, definitely.
You mentioned it's a large Cisco network. Is it pure Ethernet, or do you have any fiber channel on that?
No, there's fiber channel.
Yeah, I'm sorry. So the question was, is it just Ethernet in this large network, or is there also fiber?
Yeah, there's fiber, mostly on the aggregate switches on their own.
There's fiber channel. How about the SAN fabric on those switches as well as the Ethernet fabric?
Oh, yeah.
All right.
Is there a keyword or some sort of secret handshake that we use to, when we contact Cisco support, to make sure that we can get this on our devices?
I'm going to let Gerard answer that question.
So for enterprise support, so there will be a direct path through SaltStack to TAC internally within Cisco, and that is the supported path. Now, what we have seen with other open source tools is that a lot of times issues are raised through GitHub, and Mike is...
Yeah, I take those. Yeah, if the issue comes through GitHub, obviously the open source community, jumps on those as well. But if there is an issue specifically to NXOS, we monitor GitHub links and issues and.
Yeah, so these are and Mike can go into these. But there's a CI/CD pipeline within Cisco from this going forward that these are all validated internally and are supported by Cisco. So that infrastructure is in place.
Yeah, I kind of skipped over that slide. I did want to mention, actually it looks like that slide disappeared. Yeah, so it disappeared from my slide deck, not sure where it went. But we do actually provide kind of CI/CD pipeline to basically validate a lot of these execution module states across different versions of software, different platforms. So we've got a whole matrix. So if you contribute something to open source or Salt Open, we'll suck that down automatically and run it through our pipeline.
And what about
It's a great question. So I only handle, unfortunately, I only handle the NXOS side of things. We'd have to get you in contact with other people that handle XE and XR. Yes.
The GuestShell, is it possible to manage the GuestShell environment itself via Salt under the upgrade or so how do you keep it separate from the switch managing?
I mean, you could definitely manage the GuestShell environment through a proxy minion. So there'd be no problem with that because you can actually, using the proxy minion, you have access to the CLI commands. And so you basically just spin up GuestShell using the CLI. You can actually size it, specify the amount of memory, boot flash storage space for the root file system, plus whatever applications you're going to install on top of that. So you could actually manage that using proxy minion. We don't have any salt states around that or execution modules, but that's something that we could look at. I hope that answered your question.
You're more asking if you have a CentOS running in the GuestShell, could you manage the CentOS in the shell?
Yes, you can.
Yeah.
Yes, absolutely. Is that a question for Nate?
You could do that. I'm not, because all the servers are black boxes to me. It's all customer equipment. I can't touch it. But yeah, if you have the server and the switch, have Salt update the gateway on the switch, send a beacon back, and have that reactor catch it, and then update the switch. I think that'll work. I haven't tried it. Oh, with that? No. No, but like said, we really haven't been working with it too terribly long, and I'm the only person working on it, along with other things. So if you want to come help me, that would be great. So we are still kind of in the early stages of getting our network situated and getting our feet wet. And mostly just wanted to come out and say, hey, proxy minions aren't that hard. It was pretty easy to get it set up and start talking to switches and get it to do things. I mean, it sounds silly, but just being able to have a network engineer show interface across 100 devices that he's interested in and pull it back as JSON and filter it for him has just been hugely helpful for the guys that work with it. Now, they can do something like that instead of having 20 tabs open in terminal settings, trying to type the commands in manually.
Cool. All right, I think we are at our time limit, so we'll be up here. If you guys have more questions, we'll stick around for a while, and you guys can ask us anything else you want. So thank you for coming to our session.